Okay, so polynomials is this unit, new unit. So a polynomial is the sum or difference of many monomials. What's a monomial? One term. So for example, 5x, or just 5. That would be a monomial. So a polynomial is a sum or difference of many. So standard form, here's an example of the standard form of a polynomial. Here's an example of a standard form. What did I do there? What's happening here? What order? You're right, they're in order. What's in order? The exponents. And what kind of order are they in? Smallest to largest or largest to smallest?
Largest to smallest.
So they're descending order. We're going to be doing some adding and subtracting of polynomials today, and you're going to want to put them in standard form when you get your answer. So, some examples. We want to write the polynomial number 1 in standard form, 3x plus 1 plus 2x squared. So, what comes first?
2x squared.
Yes, because, why call it, Cohen, sorry. Because that's, and what about that 2? What is it in relationship to the other exponents? Yeah, that's right. It's the biggest exponent. We want the 2x squared first, and then what comes next? 3x, and then plus 1. Okay, so number 2, what's the highest exponent on that one? 7k to the third. And then what comes next? K squared. What comes next after that? Minus k, and then plus 64. I think you got the idea. We are going to skip 3 and 4. I want you to do number 6 as a U try. We will come back and talk about number 5. Do number 6 as your U try, and then we'll talk about it. Did it work 4? It's right up on that.
So
when everybody is done writing on these, if you could put them together in a pile, and then I'll collect them later. You don't want to select each one individually. Okay, so let's see what you got.
mine never lasts. I would almost probably win the place. Unless the last one. You don't know.
Oh, no.
I know they got it correct. And we sit together and we like a lot.
Okay, everyone who's checked has gotten this one right. Okay, quiet please. So that's the answer on number 6. Questions on that? Okay, number 5 is a little different. When there are two variables, what we do is we look at the variable that comes first in the alphabet. Which variable comes first in the alphabet, A or B? A. And so we start with the A and we go in descending order from the A. So which one would be first here on this? A to the third. That goes first. And then what would come next? 5a squared, b squared. And then what comes next? 2ab, because there's an A there. We don't do this very often. And then last comes the 2b to the third. So again, we go in alphabetical order. So we go with the A's. Exhaust all the A's, and then we go to the B's.
But then isn't it also the highest?
So, but that's only if there's. We haven't even talked about if there's more than one term, or did we talk about more than one term? I don't remember. Let me go back to that. Shoot. What happened to that?
Oh no.
So we haven't even talked about that. We just said exponents in descending order. Yeah. So, but when there's more than one variable, it's a little different. We go from the first that comes in the alphabet and then down to the other. So the degree, we're going to talk a lot about degree this unit. So degree. So the degree is going to be usually, actually I'm just going to say highest exponent. If one variable. Okay, if there's more than one variable, it's complicated. We don't do more than one variable very often, but what we do is we add the variables within a term if there's more than one variable. Add exponent, excuse me, in each term. And it's in each individual term. So what the degree ends up being the highest of those. So 5 is the only one that I have there that has more than one variable. So we look at each individual term. Okay, so within this term here, we are going to add the exponents. What do the exponents add up to in this term here? What do the exponents in this term right here add up to? 4. Okay. Is there any one of these that's any higher than that? What would the degree, what would this add up to? What would those exponents add up to? On this one? On this one, what would the exponents add up on 2ab? What would the exponents add up to? 2. So 1 plus 1 is 2. So 4 is going to be my degree on that one. We don't do that very often, so don't worry about it if you don't understand that. Really, what we want to look at is that highest one for one variable. Okay, so we're going to classify polynomials next. So we classify them according to the degree and the number of terms. So here's an example. Degree of 0 would be, say, the number 8. So if I put a variable next to 8, what would the variable be in order to keep it equal to 8? Not 1. That's no common guess, though, because then it would have an exponent of 1. So if I had an x there, what would the exponent be? That the only exponent I could put there on that would be equivalent to 8 when I write it there. What's less than 1? 0. So this would be like 8x to the 0. So this is a degree of 0, and it's called a constant. Because really, we don't need that x to the 0 there. It's just the 8, just a constant number. Okay, 1. An example of a degree of 1 would be, say, 3x. What's the exponent on x? 1. So that's why it has a degree of 1. So the name for that, if we were to graph y equals 3x, what kind of graph would we get? It goes by the shape of the graph. What's the shape of a graph of y equals 3x?
Oh, yeah.
You got it. What's the shape of a graph of y equals 3x? A line. So this is called linear. So an example for number 2 would be, say, x squared plus 5. Quadratic, that's right. So this is called a quadratic. So again, the degree is named according to the shape of the graph. So 3, an example would be, say, k to the 3rd minus 7k. So what kind of shape would the exponent of 3 be? What would that be called? Any idea? I know we haven't graphed them before, but what do we call an exponent of 3? What's another name for it? Starts with a C. Cubic. So it's going to be cubic. So we call it a cube, but we call it a cubic graph. Okay, what about an exponent of 4? You probably have not heard this one. Let's say 3x to the 4th. And we call that these coins. There's how many? There's 4 of these coins in $1. What are they called? Quarter. So this is called a quartic. We have a name for 5. It's called quintic. I'm not asking you to memorize that. When we go past 4, we just say what that number is. So if it had a degree of 5, we'd say 5th degree. Degree of 6, 6th degree. Degree of 7, 7th degree, and so on. Does that make sense? Okay, now number of terms. If there's one term, it's going to have an omial at the end, or naming by the number of terms. What's the name when there's an omial at the end? Monomial, that's right. What if we have 2 terms? Binomial, that's right. Bicycle has 2 wheels. So 3 terms? Trinomial. And then 4 plus terms would be polynomial, that's right. So what happens, and sometimes students get these 2 mixed up. So the number of terms, all of them end in what? Omial. So all of them end in omial for the number of terms. But for the degree, it's according to what the shape would be, if it had a degree of 0, 1, 2, 3, or 4, and so on. Okay, an example of 6. So 6 would be what according to a degree and the number of terms? According to the degree, what would that be? You want to give the name. Constant, that's right. And then we have one term, so it is a constant. What's the name when there's one term? Monomial. I know it's really easy to get the two mixed up. I gave you a lot of words today too.
Linear.
Yes, good. So -2x is going to be a linear, and then what do we name it according to the number of terms?
Binomial.
I've heard that every single class. You're not the only one. It's not a binomial. That's okay. That's okay. It's not a binomial. It's a monomial.
Why is it monomial?
So why is it a monomial? There. One term. Okay. That 2 has in the front has nothing to do with it. That's just called a coefficient.
Huh.
But again, every class I've had at least one person say that. So number 9, let's see, let's skip that one. Go to number 10. What would that be called? Trinomial, and then what according to its degree? Good, quadratic trinomial. And then number 11, what would this be? Cubic. And what is it called? Binomial, because there's 2 terms. Does that make sense?
That makes sense.
So go ahead and do number 12. See if you can do number 12.
A lot of work.
I want you to do that on your own. This is a you try.
Yes. You understand yourself?
Can't say it's quadratic.
No. You understand how you said?
Yeah.
I'm not asking the question. No, that's not what I said.
I would not go on that.
You better. That's a lot.
So I want you doing this at your desk, please. You should be doing that number 12 right now. Squat. Isn't it?
Have a little look.
Okay, so for number 12. You should get quartic polynomial. Questions on that?
What is a quartic?
Quartic?
Yeah.
There's a degree of 4. It's called a quartic. So look under the degree. That's a degree of 4. So what's your highest exponent there?
4.
Yeah. So that's your degree.
Okay.
So it's not in order. It's not in standard form.
So the second word is usually not termed, right?
Number.
Yeah. Number. Yeah. And then the first word is just your highest exponent.
You switched it.
So for example, there's 5. What is it? 5.
You just say 5th degree. Good question. Okay, we are going to skip 13 and 16. Pay attention, please. Most of your homework is going to be on. So when we are subtracting, what's the first thing we do on number 14? It's the hopscotch. We have another name for that besides hopscotch. Yeah, so we are looking at distributing this -1 into all 3 of those. So 4x squared plus 5x Distribute the negative for me, please. That group back in the corner. Far corner. What do we get when we distribute that negative? So does it become a positive 7x or negative 7x? Negative 7x, and then what else? And then what do you think? Is that going to be a positive 3x squared or negative? Yep, that's right. And then -1. And now we want to add our like terms. So we're going to put this in standard form. What's our highest exponent? The x squared. So we're going to add those terms together. What does that add up to?
X squared.
X squared. You can cross them out once you have added them, just to clear it out a little bit. And then we have these two like terms here. What do they add up to?
Negative 2x.
Negative 2x, and then we have a -1. Does that make sense? So what do we do first on number 15? Distribute. Good. 3v plus 7v4 minus 8. This is supposed to be a v here. 2v to the third minus 4v4 plus 8. And then we distribute our negative. So that gives us -7, -8v, -5v4. What's our highest exponent here? Because we are distributing this -1 to everything inside that parentheses. Yep.
I don't like this.
So, what's our highest exponent?
The 7v4.
Yeah, so we've got this one, and this one. What does that add up to?
I don't know.
-2v to the power 4.
Yep, -2v to the fourth. So did we do anything with those exponents when we added?
No.
No, we just added the coefficients, the number in the front. So the next highest exponent would be v to the third. So we only have this one term. Plus 2v to the third. And then what next?
Minus 8v.
Yep, so we have a -8v and a positive 3v, which adds to
Minus 5v.
-5v. And then I have a positive 8 and a -8. And so then it's going to add to -7.
You're